cursors all at the same time. And here the GTK3 actually supports it transparently, although I haven't tested it. The main thing here I need to point out though is that touch is not the same as a pointer. When you're using a mouse, there's state attached to the mouse, both virtually and mentally. So what you're doing at the moment is you move your mouse, you select the color green. The application then attaches the color green virtually to that particular pointer. So if you walk away and you come back, you move the mouse, start drawing, you know it's going to be drawing in green because mentally we've attached the state to the cursor and the mouse combination. Right? And the applications can rely on that. If you have 15 cursors on the screen, 15 people working simultaneously, you can use the cursors to differentiate. You can't do that with touch. Because one of the main features with touch is that there is no state, but we still have all of the user concept. So I give you one example. We have a drawing application. I might select the color red and start painting in red. Or I might select the color red, start painting in red, might select the color green and start painting in green. And now I expect that my left finger paints in green and my right finger paints in red. This is the user context I'm talking about. What the application sees, however, is it sees a touch point appearing here and disappearing. It sees a touch point moving around here and disappearing. It sees a touch point appearing, touch point moving around. There's no state attached to any touch point, and there's currently no hardware that I know of that can easily differ between fingers. So there is some work going on finger orientation. There's some work going on, so some hardware or software behind the hardware can actually tell that this is a thumb based on certain orientations, but we can't really, at least the data we get from the kernel doesn't have it. All you see is a few touch points appearing, disappearing, and there's no context to it. So this is one of the big risks when you're writing a UI, is suddenly all this state that you used to be able to rely on, you can't really anymore. One example here, so we imagine this is a window. We put one finger down, we put two finger down, that's quite easy because what's the user going to do? Probably two finger scrolling or something. That gets more interesting when we put a third finger down. This could either be a three-finger gesture, so say minimize window or whatever it is, but the same data we would get if you have a two-finger gesture and then we just select something here because we're about to move an object over here. The data that you see in the application is exactly the same. So one of the tricky things we face in X, for example, is that where we're going to send that third touch point to. Is it part of that first gesture, or is it going to go to some other window? And it turns out this is not solvable, at least not on the technical level. There's nothing you can do about that. You just cannot know, not with the hardware we have at the moment. So right now what we're doing is we would actually send that third touch elsewhere, so whatever application is underneath that position. And it is up to you, if you're writing a UI, to not make that situation happen, ever. So the UI has to be designed that there's no ambiguity about what's going to happen with a specific touch anywhere on the screen. And it turns out this is tricky enough as it is. Another example, we all know that. You do that, what happens? You most likely zoom. Except in this situation where there's two objects underneath the finger. So instead of zooming, what you actually wanted to do is move those two objects together. So if the application now zoomed because all it saw was that pinch, that is not what the user expected. So again, very little state, a lot of user concept. This is a particularly good example for X because we don't actually know what is at that position. We know that there's a window, so we're fine, we just sent the data to the window. But we don't know whether there is an object underneath or not. The application is the only one that knows, or the toolkit. So just a couple of examples here. We'll come up with some more. Let's look at the actual technical stuff. I'm talking about the X input extension version 2.2 here because that is where all the features went in. So yeah, it's in the X server. When you're writing a toolkit or when you're writing any client application, what you're actually looking at is the XI 2.2. The data we get in X is one of two kernel protocols, even though we ignore one of them. So back in 2631, which is probably 3 or 4 years out now, protocol A for multitouch was added, which is for hardware that does not do finger tracking. So rather than getting the fingers on its own, you just get a frame, a snapshot of the frame at the end of whatever cycle the hardware has. So you get, say, there's a touch here, 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 here. Next frame, there's a touch here, 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 here. And no tracking whatsoever. There's a little tool called mtdef that we use underneath the FDEF driver and underneath the Synaptics driver, which does the hardware tracking for us. And what MTDEF spits out is protocol B, which is also what the kernel gives us for devices that do hardware tracking. So in a reasonably good device, the one I've got built in, I'll show that off later. The data we actually get is really, we have 3 touch points here and here and here. And then what the kernel tells us is like this touch point has moved, this touch point is moving, this touch point is moving. So it really only gives us the touch points that are moving instead of the whole frame all the time. As I said, MTDEF converts A to B. So we in X, we actually don't care about protocol A, we just want MTDEF to do that for us. One of the big concepts that we've had to introduce for XR2.2 for the touch support is that we can now have one device, but we can have multiple virtual input points. Before that, you had one mouse, and you had one input point, the cursor. Move around, whatever you did on the mouse was reflected in the cursor, and you could only interoperate with one application at a time. With touch support, because you can put down 10, 15, 20 fingers, depending on how many you have on your hands at the moment, we actually need to be able to have one physical device interact with several applications at the same time. So for that example where you have 2 windows and you want to scroll both of them at the same time. That's 4 touch points, and they need to go from the same physical device, and you need to go to 2 applications at the same time. So this is the new concept there. So internally, to some degree what we're doing is we're treating touches as mini devices that just come and go all the time. So that an application that grabs a device because it needs exclusive access to the device will have just that touch point. Meanwhile, you can operate on anything else elsewhere as well. When I talk about touch devices, we have to make a distinction between 2 different modes of devices. There is a direct device and a dependent device. For a direct device, it's easy, it's a touch screen. You walk up, you press somewhere, stuff happens exactly where you press it. For a dependent device, for example, all the multi-touch capable touch pens, they are dependent devices. Because the big difference here is that regardless of where you actually use the touchpad on its own device coordinate frame, if you touch the touchpad in the top left corner, you don't actually want to select what's on the screen in the top left corner. The touchpad always works in relation to the pointer it's controlling. Up to a point that if you use a touchpad with one finger, all you're doing is control the pointer. Only when you start using multiple fingers on the touchpad, that's when you actually want to use the touch features a bit. So the multi-touch features. So these are the dependent devices. I'll get to that later a bit in what way they differ. But if you have an application, you actually need to be aware of which devices are connected to this computer and which device is currently being used. Because the user interface you can present for direct touch device is significantly different to the user interface you can present for multi-touch capable touchpad. We've introduced 3 new events. That was pretty much all it took. Well, there's a 4th event, I'll get to that later, but the 3 main ones are touch begin, touch update, touch end. That's pretty much it. You press the screen, you get a touch begin at that position. As it moves around or as it changes, you get touch update events, and then you always get a touch end event. Just signaling that this touch is over now. One of the reasons why we need the touch end and why we always need to send it to the clients is because each touch is associated with a unique touch ID. And we reuse those IDs to some degree. I mean, we reuse them once we've exhausted a 32-bit range, which means you might see a new reused touch ID every couple of years. But nonetheless, the important thing is we need to send that end across and signal to the client that, hey, we don't use that particular touch ID now. Right? Other than that, the information stored in the touch events is virtually identical to point events. You get an X position, you get a Y position, you get whatever axis else that particular touch point has. So we have currently the kernel supports pressure, orientation, width, height, and tool. We don't support that actually. But yeah, a couple of more. So if you change the pressure, you still get a touch update event. It's not purely restricted to motions. Touch ownership event is a special thing for grab handling. I'll get to that later. Touch events are delivered like pointer events, as in if you have event selection on the window, you will get the touch event relative to that window. Same thing as how it works at the moment. It works for direct touch devices. Wherever you click, the window underneath will get that event. For dependent touch devices, so touchpads, the window that gets the event is always the one underneath the cursor. Right? So if you move with your touchpad somewhere, you move into a window and then you use 4 fingers on your touchpad to swipe, all those 4 fingers will actually go to that window that currently has the cursor. As I said. In terms of dependent devices, we've only added that to the protocol documentation yesterday, I think, or 2 days ago. It's up to a point that on a dependent device, we define a mode where you use the touch device exclusively to move the pointer around, right? So usually on a touchpad, that is if you're using one finger, we assume that the intent of the user is to only move the pointer around, and we won't actually send touch events for that one finger. As soon as you put a second finger down, that's when we know, okay, this isn't just to move the pointer anymore, this is a touch gesture. So that's when we start sending touch events. Up to the point that at that point in time, we will send a touch begin event for the first touch, and a touch begin event for the second touch. Then you get the update events as you move around. And then once you lift the second finger, you get a touch end event here, and you get a touch end event here, because you've now switched back to the mode where you're just using it as a pointer movement device. Right? Make sense? Hopefully. For grabs, I don't know how much of you have dealt with grabs actively. If you've written a toolkit, you've probably had several hours of swearing at grabs at various stages. Grab delivery behavior for touch events depends on the touch ownership mask. So that's that fourth event I mentioned before. For most applications, you never have to worry about it. Toolkits don't necessarily have to worry about it. GTK, for example, lives quite happily without it. Is that right? Yeah. But if it's there, you need it. If it's there, you can use it. The Ubuntu stack, the UTouch stack, they have a gesture recognizer running in the background, and they need that for performance reasons. First of all, what is a grab? A grab intercepts an event before they deliver it to the true target. Window managers make heavy use of that. If you take your mouse, you click into a window, the window manager gets that event first. The window manager brings the window to the foreground and then tells the X server to replay the event on the actual window. Right? So it's essentially an event interception, you can replay it then. For grabs, you can basically do the same thing. You can intercept the grab. Actually, sorry, somewhere at the, yeah, just do that first. So for a grab, if we have the window hierarchy on the left here, if you click into a window, the first client that has a grab on the window gets the event. Then that client needs to decide what to do with the grab. So it has to either accept or reject it. And once that is done, it just goes on to the next client. This is pretty much like pointer grabs work, with the exception that touches always have to be accepted or rejected. Right? So if you're issuing a grab on any window for a touch event, it is your job to say, yeah, this grab is for me, so you accept it, so no one else is going to get it. Or you reject it, you say, no, this is definitely not something for me, so you just pass it on to the next client. In the window manager case, make it a bit easier to explain, is that the window manager would have a grab on any touch. It would get that touch, it would bring the window to the foreground and then say, reject the grab, because I've done what I needed to do, someone else can have it now. And that way the touch is then delivered to the next client underneath. So you get that sequence, like touch events first, reject it, touch events next. As soon as a client accepts it, that's it. No one else is going to get that sequence. And that touch event sequence until the very touch end is only delivered to that client that has accepted it. It gets a bit more interesting once you look at touch ownership, because what happens then is that we send the touch events to any client in the stack that has a touch ownership mask set. So in the extreme case, unrealistic, but if you have 5 clients that all have grabs and nested windows, we're going to send to all 5 clients at the same time if they have the ownership mask set. But only the first client actually owns that particular touch, and once that client has accepted or rejected it, that's when we pass on the ownership. So if the first client, do that again. So first client owns it, so we send that touch ownership to the first one. So the window manager, for example, can now say, yeah, this is mine or this isn't mine. If it rejects it, we just send an ownership event to the next one. So rather than previously, we just sent the whole sequence on to the next one, you replay all these events. In this case, we can assume that that client already has all the events up to that. So all we need to tell it is this grab is now yours. Right? Why would you do that? Performance reasons. If it takes you about a second or two to recognize a gesture, you don't want to wait until the grab is actually yours to start gesture processing. Right? Because it might take the window manager a second or something to decide whether a gesture is for them or not. So if you select for the ownership, you get the events as they occur on the hardware, you can start your gesture processing, but by the time whoever is above you in the stack says, yeah, this is your grab now, you already know if you want that gesture or not. So it just removes a little bit of that delay. The problem with that is that you get touches that aren't actually yours. Because someone above you, the window manager, may say, oh, this is a gesture for me. So I'm going to accept it, and then no one else is going to get anything. So if you do anything in response to a touch event that you don't actually own yet, you have to be able to undo it. If you open a file, better close it quickly again. If you do any graphic response to it, you better undo that, or you have to be able to undo that, which isn't always the case. So again, touch ownership, most applications will probably never use it. There's a few use cases. If you think you have one, talk to me, I'll talk you out of it. Point emulation is quite a difficult problem, but very important problem, because we want touch devices to be usable on your standard desktop. So right now here I run a normal Norm 3 Fedora 16, and I can use my touch device anywhere on the desktop, including inside multi-touch applications. The way we do point emulation is automatic inside the server. For every first touch, we start emulating a pointer, and we start sending pointer events where required. So I put one finger down, you'll see the cursor jump to that position, and then as I move around, the cursor will follow that finger. If I move on top of a multi-touch application, the application underneath will get the touch events. If I move on top of a normal application, the application will get pointer events. So inside the server, that touch event that we receive, we just flip it to send the right event down the wire, depending on what application is currently the recipient. Up to the point that with that grab ownership replaying, blah, 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 that I mentioned before, like the window manager might get that event as pointer event, reject it, and then we send it on as touch event, it gets rejected, we send it on as pointer events, and so on. So the event might actually change state a couple of times during delivery. Hilariously. Emulated pointer events are marked, so GTK, for example, needs to register both for pointer and for touch events, because you might be using a mouse and a touch device at the same time, and you need to get both. So those pointer events that are emulated, that are the result of a touch, they have a little flag set. So if you're handling touch events in your application, you simply discard anything that has a pointer emulated flag set. That's the easy way to do it. So we do mark the events. Yeah, demo time. So this is going to be interesting to... I don't know if you can see that, it's not going to be that exciting in there. But I can move the window around just normally by touching, and you can see how the cursor just follows my finger. If I put a second finger down, nothing is happening here, because the pointer emulation only works in the first finger. It's not as intuitive as you would hope, because one of the side effects that you get is that when you're moving on the first finger, you see the pointer follows. I put a second finger down, nothing happens. I lift the first finger up, and now you expect that when you put it down, it would follow your finger again. It's not. Because what the X server does internally, it says like, we only do point emulation if the new touch is the first touch on the device and there's no other ongoing touch at the moment. It means it's not quite as intuitive as it could be, but it's a lot safer, because the other option is you do the point emulation, you put a second finger down, you lift it up, and then you just double tap with your right finger because you wanted to do a right finger click, and suddenly the pointer jumps there and closes your window. That's the main reason why we chose the less than intuitive approach. In terms of actual multi-touch support, one of the cooler things you can see here, gedit is just the system installed one. That's just the standard Fedora 16 one. So I'll just copy some text in there. And what I can do now is I can, for example, scroll this like this. I can select text by double-clicking, and by just holding it on, I get the right click here. And that's just implemented inside GTK. So that's GTK from the multi-touch Git branch, but still stock gedit. So that's built into the widgets. Is that merged yet?
No, not yet.
Oh, okay. So it's not merged yet, but it will be hopefully soon.
Yeah.
And the other one is... this is the GTK multi-touch demo. And that is an application that actually does support active multi-touch. So one of the things I can do here, and then I can do the pinch and zoom and whatnot. And you can operate, sorry, the mapping is out because of the projector, the mapping is out, so it doesn't actually follow the field without calibration. It's a bit harder. But yeah, you can obviously move two at the same time. And where it gets a little bit more interesting again is you can have your normal window, you move that around through point emulation, but at the same time you can still use the oh yeah, there you go. So you can use the multi-touch events while you're still using point emulation in another one. And that goes across applications.
So we need to make the window manager and the root window using point multi-touch events instead of mouse emulation to make that more useful.
Yeah, if you want to use multiple windows, if you want to move multiple windows at the same time, it should be touch events, yeah.
What graphics device is on that laptop?
Some Intel.
It's not Intel?
No, it is some Intel.
Why is it tearing so bad?
I saw that too, yeah.
I think that's the Intel driver from a couple of days ago. So. Yeah.
Ouch.
Oh, because it's mirrored. It's probably V-blank synced on the internal monitor.
Oh.
Ah.
Yeah, I was wondering, because multi-head we should handle that fine, but
Yeah.
mirrored.
Mirrored, yeah.
Right.
Take your monitor.
Yeah, that's pretty much for the demo actually. So just a quick summary here. So we've got 3 new events, 3 that matter, plus the ownership event that matters for some applications, but only very, very few. Touch grabs, if you have a grab, you must accept or reject it. Otherwise, you literally hang that particular touch and cannot be used by anyone else. Touch ownership changes the event delivery, as I explained before. I'm quite happy to explain it again if you think you need it. And the point emulation is handled transparently inside the server, so you don't need to worry about that at all. So any questions?
Isn't there a coordinate transform matrix to prevent what you had, the problem you had?
Yeah, but that requires more than 2 minutes of preparation. I didn't think about it. There it is. Calculating the actual matrix so it maps to what I see at the moment.
There's no UI yet for configuration?
We only have UIs for mapping it to a certain output, but we don't have a UI for mapping it to a subsection of the screen, which is, if you look at that, the problem is that this currently maps to here because I didn't expect the screen to shrink. So it worked great at home when I didn't have a monitor plugged in. But yeah, that could be fixed with that. Okay. Thank you for coming.